Dear students, first of all, I would like to read the regulations. It will be for preparation to the exams will be 20 minutes. And order of the students will be first Nazım, Kerimбек Nazım, then Sabitova Sabina, then Sisimoli Konuş. Okay, you can write your on the paper, and before answering, you show me your paper and the answer. Then we'll next students will answer. Okay. So 10 p.m. I think we can start our exam. First of all, please, Sabina. No, sorry. So show the screen of your show us your screen and open account on Universe system. Yes. Choose your ticket. So, approaches. And the third is about poultry, okay?
Can I start?
Yes, you can start. 10:03, you start, you're preparing. So, okay. I think, Sabina, you also can start choosing your ticket.
Okay.
Show me, please, your screen. Screen demonstration. Sabina, your questions, I can't see it. Food nano
Food nano
classification.
packaging classification, yes.
Uh-huh.
Then NanoFood and its materials as nutrient delivery system. Then nanotechnology usage in Kazakhstan.
Okay. You start. Okay, you can start. And let's 10 after 3 minutes. Once you can start choose your ticket. Okay.
Oh, okay.
Let's konuş. Mustafa. Concepts. Okay. Can start here. you shouldn't use any information service.
Mhm.
This is Mazam, are you ready?
Yes. So can I use my ID and my particular?
Please don't switch off the camera.
Switch off.
No, don't do it.
Okay.
Don't do it.
Yes. So my first question is the approaches in nanotechnology. So there are like two main approaches. It's top-down and bottom-up. The top-down approach, it's forming from like large substances, the small structures, and in top-down approach, we like with some methods like lithography, ball milling, grinding, cutting, and others. And in bottom-up approach, it's like
One
forming.
second, please, Nazem, can you show us your writing? Your writing.
JC.
Okay.
And here's
Okay.
the third question.
Okay.
Bottom up, it's from small to large clusters. For example, with help of like a chemical synthesis or molecular synthesis or the growth of like atoms or some molecules, we can create and form some large, big clusters. So like there are like three types of nano sizes or nanomaterials. Like if nanomaterials have like one dimension, it's it's called like layer. If two dimensions, it's like clusters or nanowires or nanotubes, or for example graphene. If three dimensions, it's like fullerene or like nanocomposites or big nanoclusters. So, with help of these two approaches, like top down and bottom up, we can form different nanomaterials. For example, engineered nanomaterials, like organic or inorganic or surface functionalized nanomaterials, nanoclusters, some liposomes, nanoliposomes, nanotubes, carbon nanotubes, nanoclays, nanosensors. So, and then we can use these nanomaterials in different fields, like for example in food industry. So, in food processing or in food packaging, and in agriculture. So that's all for first question about approaches.
Okay.
And second question is nano market and migration research, because nanotechnology has like wide application in different fields. So it's like developing science, and there are like top countries that already use nanotechnology in food industry. So like USA, China, Russia, Iran, South Korea, Canada, Indonesia, New Zealand. So they have some nanofoods on their market. For example, Nestle, some companies like Nestle, Unilever, have like already they used nanotechnology in production of their food products. For example, they produce some ice cream with low fat with help of nanotechnology. And for example, in Monoprix supermarkets, also they have on their markets some nanofoods. And why we can use nanotechnology, because it has some benefits, like extending shelf life of food products, more hygienic processing and production of food products, high quality of food products, and nanotechnology can help to save some flavors or nutrients of food products, and also it helps to improve some chemical and physical properties of products. But also nanotechnology has some risks. For example, it's safety concerns, and it can impact on our immune system, on our health, and also then we can people can have some diseases like liver or kidney diseases, some inflammation diseases. So for that, in USA and Europe countries, or maybe in developed and developing countries, they have we have some safety regulations like FDA or Environment Protection Agency in USA. it was developed in 2011. So they have like a conference and some like paper that about like safety concerns and safety regulations on nanotechnology, on usage of nanotechnology in food industry. So also in South America, there was like Brazilian forum about the labeling of nanofoods, and it was like how to say, it was decided to have some label need to have the word nano, and also like claim that do not eat, because it's for example for nanosensors, because people may like how to say перепутать мы okay yes may concern this as edible sensor or as an edible component of food. And so about migration, nanocomposites and other nanomaterials can migrate from the food product to our tissues of human tissues, and they can accumulate in these tissues. So it has some, it can affect on cells, on our cells, like on cell membrane, or like our mitochondrial composition. So it then can some risk, it can have some risks. So for that,
Switch on your camera, please.
But I have the
Yeah, you
I
have,
switch
but Manush and Sabina. Okay.
But our cameras are
Okay.
working.
Yeah.
And for detection of this migration, we can use some methods like spectroscopy or chromatography, and then we can detect if there is migration or not. So the big like disadvantages of using nanotechnology is it's the possibility of migration of these nanocomposites and nanomaterials.
Okay.
So,
I have one question.
Okay.
Just, what about the market of Russia? Close to us is Russia, and which aspect of food industry they use nanotechnology? In which aspect?
I guess they use nanotechnology in food packaging.
Yes, you're right. You're right. You can continue.
Okay,
Third question. Yes.
The usage of nanotechnology in poultry production.
Poultry production, yes.
Yes, so there are like two main pathogens in poultry meat. It's Salmonella and Campylobacter. So nanotechnology can help us to detect these pathogens. For example, with help of some sensors, some biosensors. Or like there are like also another types of sensors like electrochemical, like electronic nose and tongue, optical sensors and bio-based nanosensors. So also we can like we have like tracking sensors that can trace food products, or can like give information about the durability of food products. So and also these sensors can detect some presence of antibiotics in tissues of poultry meat, because in the production of poultry meat, many manufacturers use different antibiotics and hormones and some like growth stimulants to have bigger meat, or maybe bigger meat, and so these sensors can detect the usage of these components. So also another application of nanotechnology is the usage in how to say, usage of metal oxides like zinc nanoxides or titanium oxides or copper and other metals to prevent the growth of biofilms, the growth of microbial biofilms on surface of equipment, or yes, on surface of equipment in during the manufacturing. So it can prevent the cross contamination. For example, when the chicken meat can in contact with the surface. So and also another application, it's nanotechnology in feeding of birds, of chicken and other birds. So for example, we can use some nano materials as additives to the feed of these birds, and then to improve the quality and to improve the health of these birds. So, and about the packaging, so there are like types of packaging like active, improves, biodegradable, and smart or intelligent packaging. So, for example, in poultry production, it was a report that about the usage of zinc oxide in packaging, in active packaging, and this metal oxide can react with sulfur component. It's like sulfur. It's a main indicator of spoiled poultry meat, so it can detect the possible spoilage of poultry meat. So that's all.
Okay. Okay. Thank you. Okay. Okay. Thank you, Nazım. Let's start this case, Sabina.
Okay, so here
If you want, Nazım, you can stay. Oh, yeah.
My first question is about the food nano packaging classification. So there are 5 types of possible packaging types.
Let's first of all, before starting, show us your paper or your writing, and then start your answers.
So here it is. And on this side too. So the first question, food nano packaging classification. The first one is a biodegradable packaging, and this packaging type is as name said, is a biodegradable. It means that it's eco-friendly and made from bioproducts, organic products that can degrade and decomposited by any type of soil microorganisms easily. And that's packaging types made from maybe organic molecules such polysaccharides, mainly, for example, lignin, cellulose, and also in some cases starch. And the second one is the intelligent packaging, and this packaging type is the control physical and chemical conditions in the package. So the next one is the active packaging. This active packaging is like main and the big one that's used in the industries in the nanotechnology, and this one is control the oxygen and the release of toxins of the microorganisms, and it also controls the microbial contamination and can prevent it with the help of nanoparticles, the silver and gold nanoparticles, and also it like have sensorial qualities, and also it will like ripen the fruits and vegetables and release the ethylene, which is like the basic component of the ripening process will release it on the time, so the consumers will always get the ripened fruit or vegetable. So, and the next one is the smart packaging. Smart packaging will determine any type of contamination is used in the poultry production. So it will show that there is a contamination by the microorganisms and release of some gases and toxins. Also, mainly the release of gases, and will inform the consumers by the changing the color of the product. So they will determine if the product is green, it's safe, and it is not green. So, for example, like dark or dark brown colors, it will like dangerous and contaminated product. So, and the last one is the nano coating. Nano coating is another type of like packaging of the food, because it will save consumers from the contamination also, and also it will have antimicrobial activity. And another thing is like degradable one, which can be consumed by people, and it will be okay. So no danger for nano coating packaging. And that's all for the second question. Or I mean, first question, and then second question is the NanoFood nutrient delivery system. So talking about the delivery system, mainly in nanotechnology, it will deliver bioactive compounds to the organs or to the specific organs or to the human body. And that bioactive compounds are mainly some of them hydrophobic, and some of them can be like solubilized in, degrade in the human intestine with the release of human intestine juice, and bile acid. These bioactive compounds can be proteins, enzymes, or vitamins, minerals, and they have different functions in the body or in the production system. Because in the production scale, in the industry, these nano delivery systems could be used to add to the product, to like the same function, to increase the functional food quality, because some of the delivery systems could be used to coat the vitamins or coat some minerals to deliver to the human organism through products, through food. And one of them is the nanoliposomes. And these nanoliposomes are made from the phospholipids mainly, and from the triglycerides, monoglycerides, and so on. And these nanoliposomes have biliary membrane, which will save hydrophobic molecules from the solubilization. And one of the examples of the delivery by the nanoliposomes can be omega-3 fatty acids, and these omega-3 fatty acids are very demanding molecules in the body of human system, because these omega-3 fatty acids can degrade in the human intestine, as I said before, from the acids. And these nanoliposomes will save from the harsh conditions these bioactive molecules and deliver to the organism. And the next one is the nanoencapsulation. And nanoencapsulation is mainly made from different molecules as proteins, and it will deliver enzymes, also the vitamins and minerals. Nanoencapsulation of nidine was used in the ripening of cheese, KazNU is an enzyme that used in the cheese production. So nanoencapsulation of nuclein will avoid from the proteolysis of the ferment of the enzyme, and thus will ensure the safety and ensure the safety of the molecule of the nuclein. And the next one is a nanoencapsulation by the casein cells, because these proteins that we can find in the milk can be found also in the encapsulation. So the next thing is about the delivering of the flavorings and the additional components to the in the food production. That's all for the second question. And the third question is the nanotechnology in Kazakhstan. Talking about the nanotechnology in Kazakhstan, this field, like in the Kazakhstan, is developing. And there I can mention some institutions that are conducting research. So, for example, it's a Kazakh National University, and the Institute of Combustion that's in KazNU are made carbon nanotubes that are successfully used and conducted in the Kazakhstan. And this is the one and big representative of the development of nanotechnology in Kazakhstan. And the next thing is Tsupayev University. This university also conducting some research and discoveries on the nanotechnology, but there are no successful investments, I guess, or products. It's carbon nanotubes. And the next one is the laboratory that is located in the Shymkent. It's called NanoFab. This NanoFab is also doing research, and they are in a way to produce nanosensors, I guess. And also there are universities and institutions and also companies. For example, Ekhojan University is conducting research on the one, they are producing one medicine, and that's made in the nanoscale. Also, the Phytochemia pharmacy, company that's located in Karaganda is making. They have already arglabin medicine, which is used to treat cancer, and this arglabin made in the nanoscale, and so they made nano arglabin to increase the absorption of this medicine in the body and to the distribution in the body. And also the next university I can mention is the Nazarbayev University, because Nazarbayev University have, in comparison with other universities, they have a lot of advantage and beneficial sides, because they already use tools in the nanotechnology, and they have possibilities to accept some tools, equipment for the conducting their research. And also they have projects which is in collaborating with other countries. And yes, so in general, nanotechnology in Kazakhstan is need some improvements, because there is no regulation on the nanotechnology at all in the Kazakhstan. So there is no rules about the safety of nanotechnology and can we use in the labeling or not. And that's, there is no information about this. And also we don't have any centralized institution of the nanotechnology, because in some countries like South Korea, they have centralized institution where they control the different cities. So we need some function and centralized institute. And yes, that's all for third question.
Okay, thank you. I think you had a problem with internet, yes?
Yes.
Okay. In this case, can you send me your paper writings to my mail or my WhatsApp? Okay. I would like to read. Maybe I didn't hear. Sabina, can you repeat NanoFood classification for only list of them? First,
biodegradable
first is
packaging.
second,
intelligent
active, or smart. Yes. Second, yes, active. Fourth,
and nano coatings that are edible.
No. Improved packaging. Do you remember?
Yes, improved.
Active,
No,
smart,
I didn't mention.
improved, and bio-based.
Yeah.
Okay. 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 Thank you, Sabina. So, let's start, Juanes.
Okay. Here's my paper writing. And can I show my ID at the end of my answer? Because it's like a bit far from here. Or I should go like get it. Okay. The first question is the concepts in nanotechnology.
Your voice is cutting to me.
Weird. Okay, first question is the concepts in nanotechnology, history in food. Can you hear me?
Hello, Juanes.
Hello? Hello, can you hear me?
Sorry, no, I didn't hear your voice. Okay, you can start.
Okay, the first question is concepts in nanotechnology, history in food.
Yes. It's okay. No, it's okay.
So basically what is nanotechnology is that it's a science that examines the application and ways to create and relationships between the substances or structures that are that are very small, typically like from 1 to a few thousand nanometers. So the main two types of the nanomaterials in nanotechnology are the engineered and organic nanostructures, with engineered being typically inorganic nanomaterials that consist mostly from the substances such as metals, metal oxides, and etc. On the other hand, organic nanomaterials consist of the proteins, lipids, carbohydrates, and other compounds that can be used. There are two approaches for the creation of these nanomaterials, like top-down, bottom-up. The one is focused on the scaling down the size of the structure, like from the bulk, and from it will chip away the small particles, which will then will be separated further, thus creating the smaller nano-sized material particles. In bottom-up approach, the creation of the nanomaterial is mostly occurred due to the agglomeration of the smaller particles, which results in the creation of some kind of structure. These particles are characterized by their overall efficiency in the delivering and dispersion, for example, because they're smaller, they can be dispersed way better. And right now, a big concern about the nanomaterials is their safety, because right now there were reports about the possible effects of these materials on human health. So that's what I want to say about the first question.
I'm sorry. Hannes, I'm not really satisfied with the answer about concepts and history. I would like to add additional questions about risks of NanoFood.
Risks? Okay. So the
negative side of NanoFood.
Okay, these nanomaterials, for example, especially engineered ones, due to the smaller size, they can penetrate the intestine, the barrier of the intestine fairly easily, and enter the bloodstream. And this could lead also to their accumulation in the target organs.
Yeah.
Predominantly liver. Also, due to the smaller sizes, the surface area is increased drastically, and this leads to the amplification of their properties. For example, if we take nanosilver, just a normal, if we take a kind of a brick of silver, it will have effect on the microorganisms, but not as strong as the nanosilver does, because its reactive surface is way bigger, and thus it's way more effective on the, for example, microbial growth inhibition. But this also could mean that adverse effect that these nanomaterials could have on human health also could be amplified. And you could reach this toxicity threshold easier than if you would use a common analog of this material. Yes, these are and yes, also again about the nanosilver, it's mostly used in the packaging, but there were reports that it can penetrate the food. It's fairly easy, it can migrate into the food, and from the packaging, and this could also be a problem.
Okay, enough. Okay, Okay, thank you. Start second questions.
Application of NanoFood in processing.
Application of nanotechnology in food processing.
Application of nanotechnology in food processing. Okay, there are like several main applications. Like first of all, and one that is actually the most used one is the packaging. Second is some kind of enrichment of the product by biologically active compounds, for example, vitamins and etc. Then emulsification, in order to like create a emulsify the insoluble, like two insoluble phases of the product. And yeah, and for example, as Sabina says, I think addition of the for example enzymes and or some kind of peptides into the fermentation process, for example, and thus these like encapsulated units will be more stable and more efficient. So let's start with the emulsification. And this one we need like, so it's like small droplets of lipid that are like spread equally all over the solution, for example. This is made because if we try to like the fat can't be solubilized in water, for example. If we try to solubilize the water and oil, and eventually, if we won't emulsify it good enough, it will create two phases. Like it will create two phases. So to avoid this, we use emulsification, and this provides the kind of stability to our solution. Also, during this emulsification process, we can add some substances that can be like encapsulated in these forming little droplets of the fat, thus creating some kind of contributing to the creation of the delivery system of our product. From here we can go to the delivery or enrichment, because for example, there are a yogurt. There were okay. At some point, I saw the research that there were a group that wanted to enrich a yogurt with fish oil. But if they just simply added it into the yogurt, this would significantly alter the sensorial properties of the yogurt. The taste, predominantly the taste. So what they did, they created an emulsion, and these like small droplets of fish oil were encapsulated in lipids that are present inside the yogurt, thus creating the like a small nano delivery system. This made this fish oil more like bioavailable, since it can like it has easier time of like moving through the human's gastrointestinal system, and it also like decreased the effect of the fish oil on the sensorial properties of the product.
Okay, thank you.
And about the packaging,
yeah, I think you tried to answer more deeply. Thank you. I think it's for in second question is enough. Third question.
The third question is nanotechnology in agri-food production.
Yes.
So there are like three types of these three applications for the nanotechnology. As the nanofertilizers, nanopesticides, and as the supplementation of the animal feed. So nanofertilizers, again, these are the smaller. They are much smaller than the normal analogs. So they are not agglomerating, so they can be spread over the field much easier than if you would use the common, for example, fertilizers and pesticides. Also, like these nanofertilizers could be like could be given a capsule that will trigger on the upon some conditions and will provide us with means to control the release of the pesticide or fertilizer into the environment. They are smaller and in case of fertilizers, and thus more bioavailable. So plants could have a much easier time like uptaking them from the environment. Same goes for the pesticides because insects are much easier to get these small particles into the organisms. So yeah, and about the feeding, again, I said that these particles are smaller, more bioavailable. And for example, there were like a research on zinc, and they tried to supplement it to the supplementation. They compared the supplementation with nanozinc and common zinc in ruminants. So basically, the zinc is essential mineral, and the ruminants need to uptake it like daily, but it's not very available. So a big part of it, like just removed from the animal's body with a fecal matter, and this way it can, like, for example, have impact on the environment because a big amount of zinc just poured into the environment like every day. But when they used the nanozinc, it became more like bioavailable, and they concluded that you actually need less supplementation because like almost all of it is uptaken by the body. Than if you would use just normal zinc, and the animal body would uptake like around 30% of it from the supplementation. So you need to pour a lot of it. And this way they like concluded that this is more efficient supplementation, and it also decreases the chances that this like this metal will have significant effect, will leak into the environment. So that's what I want to say.
Okay, thank you. Thank you for your answers. First of all, please send me your writing to me. I will assess your answers and put your marks as soon as possible in your universe system. Okay, I think your answers. I'm satisfied with your answers, and that's all. I think we can stop our exams. Do you have any questions?
No.
No.
No? Okay. In this case, good luck. I wish you health. Qanash. Okay. Thank you.
Thank you.
Care yourself. Okay. Goodbye.
Thank you.
Thank you.
Bye.
Goodbye.
Happy New Year, teacher.
Happy New Year.